Thanks, Ethan. Hello, everybody. Let me go ahead and get my screen shared here and we'll get going with today's presentation. So we're going to spend a little bit of time up front here just covering some theory, some best practices, some insights into load performance testing, right? Using WireMock Cloud, where using the platform, right, we're able to achieve realistic latency and chaos at scale, right? But without any of the dependency drama you often see going against the real, dependencies. So let's hop right into the content I've got prepared. We're going to take about 35 minutes or 30 minutes, I should say, to get through not only these few slides that I have here, but also a live demonstration of running some load and playing around with the chaos settings and delay injections with WireMock Cloud. So we're going to start with why load tests often fail in the real world. And really, this is about dependencies, right? Dependencies can define your performance. So if we look at some of the trouble that we typically have in load and performance testing, right? We're typically sharing sandboxes or non-production scale environments. And oftentimes these can be rate limited, or we can have, we can have some noisy neighbors in our environments going against both internal endpoints and third-party endpoints. Oftentimes they're unstable in these lower level environments that we have access to when we're doing our load and performance testing, or they're just plain unavailable. They're brought down for no good reason. They're not in our control, especially those third-party endpoints. And a lot of times we'll see inconsistent behavior across these various different environments that we are asked to do our performance testing against. So with all of these in mind, we're not really getting accurate test over test results and testing any improvements we make. And that talks to, right, what does good look like when we are talking about performance testing and reliability testing? And that is repeatable testing, right? We want to be able to test any small changes we make to our application code, the architecture that we plan to host it on in production, or the configuration set, such as queue depths, retry logic, timeout values, and such. And in order to test these at scale and do it repeatably, we need to control as many variables as we can. And that is going, that's namely in these dependencies, again, internal or external, that we need to control. So where does service virtualization or mocking and stubbing really fit into our load testing practices? So as I was saying, right, we can isolate our system under test performance. What we're really after is testing the application that we are responsible for, and not necessarily everything that it's dependent upon. Sure, we want to be able to simulate realistic response times and behaviors that we expect to see in production or that we've seen from our observability tooling in production, and make sure that we're testing against those real world behaviors of our upstream dependencies. And that's something that service virtualization, mocking, and stubbing can actually help us do. We also want to inject faults safely. So think about trying to ask any third-party service providers that you rely on to every once in a while throw a 5xx error. Again, we see these in our production logs all the time, and we need to ensure that the reliability and the scalability of our system under test can handle these. And then, of course, we can use service virtualization to run at scale without any of these bottlenecks, really achieve production-like load tests and levels without having to have a massive environment or all of the pieces and parts available to us. In fact, we can shift our load and performance testing way to the left in the SDLC, testing individual components and microservices at production level load for really dialing in these independent components. Even better, we can start to include these types of tests in our CI/CD pipelines if we're really focused on performance and reliability of our applications. So that comes to, okay, what is really a best practice when we're talking about load testing our system under tests? Now, I started my career as a performance engineer some time ago, and things have changed rapidly, as we all know. But this is still a good strategy, right? Where we really look at generating a baseline. If everything is perfect in the world and our upstream dependencies are responding in lightning fast time, how does my application behave? Is my garbage collection working the way that it should? This is best case scenario. But then we start to stumble in, okay, now let's actually look at what are the real world expectations for our upstream dependencies? What type of response times can we actually expect? And start to dial in our performance and architecture settings to ensure that these latencies that we expect to see from our dependent calls are actually handled gracefully, and we can still reach the load levels that we anticipate in production with our configuration set and code base. And then lastly, it's preparing for the uh-oh, something's going wrong. Are we able to handle this? Can we still meet a desirable load level, even when things start to go a little bit wrong with our dependencies? Not necessarily our system under test, right? But with the services that they depend upon. So common pitfalls we actually see. Maybe you've embarked on doing some load performance testing, reliability testing using WireMock Cloud, or maybe some other tooling out there. There's still a lot of common pitfalls that we see, and I wanted to make sure we touch on these briefly. The first one is unrealistically fast mocks. So traditionally, when we're using mocking and stubbing early in the SDLC, developers might not be creating realistic response times in their stubs. They might have them set to the default no delay inside of WireMock Cloud. And when we actually go and start to test our performance of our system under test or our service under test, we need to ensure that after we get that baseline of everything's roses, best case scenario, that we actually are implementing realistic response times, often derived from either our SLA documentation from our third-party vendors or past observability results from our production monitoring systems. Another one is not having enough data variability. So sometimes we stick with just static responses, and maybe just a handful of those responses. But when we do this, we often get into this trap of hitting cached responses and really not highlighting what it's going to be like in production with responses that are coming in all shapes and forms and colors. No failure modes is another one, right? Yeah, it's great if our service always responds back with 2xx response codes, our upstream dependencies, but we all know realistically that is not the case. That is, after all, why we have retry logic and back off logic baked into our services that we're developing and our systems under test. So we want to make sure that we're incorporating those. And the last one is environment interference, especially going against real live environments. We can get some noisy neighbors in those environments. Going against third-party sandboxes, usually can't hit the performance profile that we'll get in production against those third-party APIs when we're calling them with our load and performance. Or even in a mocking world, right? We might forget that a mock API is being used for functional testing, CI/CD testing, and performance testing. And we don't necessarily want to have any interference from other teams hitting the mock API, or using a mock API that's overly complex, too many data scenarios in our load and performance testing. So what's really required in order to satisfy all these pieces? Well, lucky enough, these couple of things that we'll talk about and demonstrate today are all part of your WireMock Cloud subscription. So with the stubs, right, typically being no delay when we're using them earlier in the life cycle of the SDLC, a quick way to implement some realistic response times. Also, the chaos injection feature, right? Again, included with your WireMock Cloud subscription of being able to layer in at a defined rate a number of errors or jitter or timeout simulations, even brownouts, right? And recovery from these scenarios and being able to do these very easily. And that's exactly what WireMock Cloud provides for us. Now, I will call out that we at WireMock Cloud oftentimes have first meetings with a lot of customers who have been very successfully and happily using WireMock Cloud or WireMock standalone or the WireMock open source application. As popular as it is, right? This is often we hear a lot that hey, we're trying to scale up WireMock standalone or open source, and we're just having challenges getting to the load levels that we want. And this is some of the challenges we often hear, right? Whether it's having to provision and scale that standalone Docker image or jar file to handle the load levels you want. It's tuning the JVM that's underlying of that WireMock standalone for garbage collection, connection handling, and things like that. Distributed consistency, making sure that our data, our mappings files are in sync across multiple instances. If we're using stateful mocking, data sources and such, ensuring that that's all the same across all of the standalone instances. Well, in fact, standalone doesn't necessarily have those capabilities. So trying to replicate stateful behavior or data source behavior is a headache, right? The chaos control plane, injecting errors, just randomly injecting errors, like is going to happen in production. Again, another shortcoming of the open source capabilities. Observability gaps, or understanding what's happening underneath the hood of the WireMock open source platform to understand, hey, is it my system under test that's struggling? Is it my load injector that's struggling and not helping me achieve the rates that I want or the success ratios that I want? Or is it really my stubbing and mocking platform that is doing it? That observability, right, is solved for in WireMock Cloud. And then, of course, there's that operational overhead, trying to do this all, wrap all of these things yourselves, and spending a lot more time building a solution, maintaining a solution, and not actually focusing on the goal and the knowledge capital that you have, which is your system under test, not necessarily the virtualization platform. So how can WireMock Cloud, how do we change these outcomes, right? Well, of course, many of you who are users already understand that WireMock Cloud encompasses, enterprise grade, capabilities to solve for those challenges. So we have a global API delay and chaos. We provide you environment isolation, preventing noisy neighbors. There's the enterprise scalability of WireMock Cloud, achieving 5,000 to 20,000 transactions per second from your WireMock Cloud dedicated infrastructure. And there's the enhanced visibility into actually what's going on while you're consuming these mock APIs at such high rates. So for the demo part today, which we're going to get into now, we're going to be using a K6 load generator. It's going to be sending traffic to a Node.js application that I've got running in ECS, 6 containers, I believe, running in ECS behind a load balancer. And that system under test is going to make calls to 3 different services: an inventory API service, a pricing API service, and a catalog API service. And we're going to monitor this using Grafana, and we're going to look at some dashboards that are looking at the performance or the call rates of to the WireMock Cloud mock APIs. And we're going to demonstrate these types of, these capabilities. So what I'm going to do before we go over to the next slide is I'm going to hop over onto my EC2 instance where K6 is loaded up. And I'm going to kick off this K6 load test here. And this is going to ramp up for about 5 minutes to get us to our 100 VUs running at steady state. And we'll come back to this screen a couple of times as we're running here. Maybe I'll blow it up a little bit so it's a little bit bigger. So as that's going, let's hop into next slide here and talk about what we're going to observe at first. So in our first step of the demo, we're going to achieve that baseline run. We're going to be operating or making calls to our mock API that has the 3 endpoints representing those API calls and paths. And we're going to be doing that against no delay. So as we'd expect the initial service to be created, no delays in there. And again, we just want to ramp up to that steady state load, making sure again that as part of everything's roses, everything's sunny, the upstream dependencies are responding back as fast as possible. Do we have a consistent performance profile with no errors and observable garbage cleanup happening, but not really affecting our P95 or P99 data points, right? Making sure that tail latency is consistent. And we're going to confirm that error rate is low. So let's go ahead and see how we're making out on this. I'll come over into our mock API. This is the one we're hitting, our checkout-demo WireMock API piece. If I come into our request log, we can see lots of transactions are happening here. And just to verify, we've got a health endpoint on here, and then we've got our catalog API, we've got our pricing API, and we have our inventory API as well. And if we click into one of these, we can see it's pretty simplistic. It's a get on a catalog. We're accepting any SKU number to be passed in as a query parameter. WireMock's going to respond back with a 200. An important part here, which we'll call out in a little bit, is ensuring that we have some dynamicism to our responses coming back. We're not just dealing with static data. We want to make sure that we are busting any potential caches that might be occurring. So as we can see down in the response that's coming, that we've got some random UUIDs being sent back, and we even have a pick random in here, changing the attribute of the color for these catalog calls. And as I mentioned, right now we're operating with no delay on our responses. So we can see these coming back, no delay, and no delay. So let's hop over and see how we're doing so far. We're at about 70 VUs. We see no errors coming in just yet from our K6 instance. If we hop over into our Grafana monitoring here, and let's go ahead and just do a quick refresh here. We should see a new test run going right now. So if we go ahead and click on this run, we can start to observe what's happening as our purple line is showing our request rate is building, our gray line showing the number of VUs increasing over time. Currently, we are seeing a P95 response time of about 6 milliseconds coming back from those mock APIs with a no delay response time set. And we come down below, we can see we've got 39,000 requests to our checkout call. That checkout call making three sequential API calls, dependent upstream API calls to our mock API. And we can see a pretty consistent 18 millisecond P99 response time from our checkout test here. So we should be at our steady state at this time. We're at 100 VUs. If we come back and look over at our Grafana dashboard here, this is pulling information. Let's go ahead and make sure this is refreshing every 5 seconds for us so we can get the most recent information. We can see, okay, now we've got our information coming in is live now for the last 15 minutes. Great. So let's actually start to affect, now that we've reached that steady state, we can see that, we see some garbage collection happening here with our blue line being response times during garbage collection happening. But they are pretty much, recovering very quickly during those, after those garbage collection timeframes, still giving us a 23 millisecond P99 profile here. Let's start to affect this and start to put some real world response times. So let's come into our pricing API and let's first come down and go about this one way. Let's go into the delay here and just set a fixed delay of 500 milliseconds on our pricing calls. And with the quick change there, we can come back over into any one of our dashboards that we're using to monitor our performance. And we should start to see, some changes in our response profile here. So it takes a few seconds for these to come in. Our request rate is, still healthily building up. And we can see our response time is still pretty steady. No failures happening yet. So this 500 response time, not that much of a problem. Well, okay, now we start to see that delayed reaction, right, of our monitoring. Now seeing that, the checkout call is taking about 500 milliseconds. And in fact, we're starting to get an error here. We've got a 502 coming from our checkout process. And we can start to, fine grain look at this a few different ways, looking at latency profiles, our upstream health, and any errors that might be happening. Now, don't mind these numbers. These are counters. These are encompassing of prior loads, or prior load test runs that are happening here. What we're actually looking for is ensuring that for our upstream health, that these numbers aren't growing, right? That they're staying steady. We'll see them grow in a little bit as we get more into those rainy day scenarios. So we can see, okay, we're pretty much steady state here. We've added that 500 millisecond response time. Let's see what happens if pricing starts to struggle a little bit and pricing starts to go to a 1 second or 1000 millisecond response time. And again, it's probably no surprise what's going to happen here. We'll start to see that our checkout times start to increase. We can also see something interesting here in our purple piece, that our request rate has actually fallen down. So while we were up to, close to 800 requests per second before we started injecting real world response times, now we're coming down to about 157 is where we're averaging out here. Now we're not getting any more errors, right? So far what we're seeing is, hey, our tuning of our system here, our retry logic, our timeout logic seems to be pretty good so far, but I'd argue we're still not overly realistic as to our response time. So let's change that. Instead of using these response times down here and just playing around with individual services and changing their delays, let's do this in one fell swoop using the chaos module. In the chaos module, we can come here and say, well, let's go ahead and put some random uniform delays across all of our API calls. In production, we typically see that calls in the past to these three APIs, are somewhere between, let's say, 50 milliseconds and 250 milliseconds. So I can come down, click this save here. And now that we're closer to a, realistic performance profile, we know we're good at steady state. We played around with one service, starts to have some hiccups. Now we're just focusing on, hey, let's get to steady state with production level response times and let this run for a minute or two, right? And see, okay, now that we're set at, these response times here, what type of profile can we get? How many requests per second are we able to achieve with these 100 virtual users? Are my errors going up any higher? We can see, I'm not really generating any errors with the checkout process. I still have that one that happened some time ago with the 502, but we can see that I'm still getting a P99 of 1 second coming back for these. And on the P95, we're actually down around 506 milliseconds. Still really fast response times here. But what's really important, right, is our customers are still able to check out, even with this performance profile, the retry logic, the error handling, the back off configuration set. Everything is behaving as we'd expect it at this performance style of profile. Well, let's now inject a little bit of chaos, right? Because as we said, we all know every once in a while we get those random 501s or 4xx's. So I'm going to come into the chaos module here. I'm going to say maybe just 1% of the time our upstreams are going to produce a 501. And I'll go ahead and I'll tick on chaos here. I'm going to leave our production level response times because we want to lock in on those and keep those constant. Now let's introduce those random errors that happen for no good reason, either from our third-party APIs or our internal APIs, and see again, with our retry logic, with our back-off logic, with our timeout logic, how can I expect my service, my checkout service, to behave under this real-world scenario now? Again, we're just changing one variable at a time here and ensuring that our configuration set of our system under test is finely tuned. And we're doing this at the micro level, right? At the microservice level. Our checkout microservice this is what we're testing. We're testing it in isolation. We're controlling all the variables. The only variable that we're changing each time is either the performance of the upstream APIs, or maybe we're going to change the configuration set of our system under test to change our queuing strategy, our timeout strategy, our back-off strategy, and such. So again, now that we've changed this, we've started injecting some of those 501 errors. We can see that we're starting to get some, more failures here. So we can see, we've got a 503 that came back, even though there's a count going up to 1. This is indicative, right, of maybe hitting too many errors in a row, right? One service, even though it's got retry logic, hit 3 errors in a row. And that's what we tune to be a complete failure. So we can see that checkout is throwing that 503 ultimately here. But again, we're going to take a look at our request rate and our response times. And even though that we're now injecting, some of these errors, we can see that we're still in a really good place, right? We're still handling roughly, now we starting to see it go down a little bit here. If I can get this to come over here, we're still handling about 300 requests per second. And as far as the response times, we're still pretty good on our response times. We're still pretty steady state. We're locked into a pretty good configuration set here, I would argue, showing during this one particular run. Now, the last thing I want to show, as we've got 3 minutes left in this run here before this test shuts it down, is let's actually go ahead and implement some rate limiting. So let's say that on our inventory service that we want to actually implement some type of rate limit. So I'm going to come here and say inventory is only allowed to handle 90 requests per second. And when I click save here, what's going to happen at this point is if WireMock encounters more than 90 requests per second to this particular inventory stub, then WireMock is going to send back the rate limited error message to our consuming checkout microservice. And that microservice will then, relying on its configuration set and its libraries that are implemented, determine, okay, when should I retry? How many times should I retry before I completely fail the checkout page? So in implementing this particular piece here, we can start to see the performance profile change a little bit more. We're starting to see that checkout process starting to error out a little bit. We see that blip in the radar going up there. We see our response time has now gone up, as when we're rate limited, we have to back off, wait maybe a few milliseconds or whatever we have configured in our application configuration before it can try again up to the maximum number of retries. So we would expect that response time to go up there. But again, maybe these failure rates are somewhere, are in the range of what you'd expect, but at least we've got this understanding of, okay, if we do get rate limited based on our configuration set right now, we can see that we're starting to struggle a little bit on the checkout. We're throwing a lot of 503s because we're getting too many failures in a row with our current configuration set of our application. So we're just about at our wind down time here. I'm quickly going to back all of these off. So let's go ahead and take our rate limit off. Let's go ahead and save that. Let's come over into our chaos settings here, turn off our chaos, and let's just go ahead and go back to no delay. And we should see a nice, healthy recovery, all systems back to normal. And if we had a little bit more time before this would have ramped down, we would start to see our performance profile return back, hopefully, if our system is able to recover from any one of these particular conditions happening. So we can see right now that our response time is really starting to go back down to where we'd expect. Our failure rate is going back down towards zero, and our request rate is ramping back up. Now, simultaneously, we're also ramping down in our last minute here. So unfortunately, I got to that a little bit too late to show us we're going back to our steady state of taking off all of the burdens that we put on our upstreams. But hopefully you can see that that recovery was starting to take effect in those last 20, 30 seconds of our performance test here, our 15-minute performance test. So let's hop back over, and I didn't have enough time to actually walk through, some of these other slides, so we'll just touch on them briefly real quick. What do we do in step 2? We increase that API delay. We set, an API delay of 500 milliseconds on the pricing API call. Then we increased it to 1 full second. And we did some observing of what was happening, right? Were we getting errors, or were we still getting, a really high success rate, albeit a lower performance profile? But was that performance profile, good enough for us to go live in production? That would be up to defining what are your success criteria for each run. And then we turned on the chaos piece, right? We added more of a global style of delay, random delays fitting inside the bookends of what we observe in our production monitoring from, old behaviors or what we anticipate the performance profile to be. And then we started to inject some errors. We only did 1%, 501 errors, right? And we also did this combining our increased latency, kind of simulating that brownout of, there's a slowdown. Can we recover from it, right? And after we turn off all of those pieces, can we make sure that our system recovers appropriately? So what do we learn from looking at these signals that are happening, right? Using the P99, right, we can see that starts to explode as we start to increase our delays from 500 milliseconds to 100 milliseconds just for a single service there, right? And why is that gonna happen, right? Well, we can look at our queuing strategy, our how many times we're retrying, where our timeouts are set for, trying to prevent a pile up in requests, right, that are happening, right, that are being queued up there. With a small fault rate, right, we can cause big latency spikes. We did a 1% error rate, and we saw how latencies really started to increase because we really need to lean on that retry logic. It did look like it was tuned pretty decently so that we could sustain a pretty decent load level there, even while we were experiencing those issues from those faults. But it might take a little bit more playing around to understand where's the sweet spot of tuning that retry logic, that timeout logic, and that back off logic. And then this last one, errors stay bounded and recover. So we saw that as we changed, response times, and then we backed them off again, we saw that our system gracefully recovered. Our checkout service was able to, during a brownout, recover, come back to those high levels of performance we'd expected. And the same thing we started to observe when we took off chaos and we went back to no delay, that the system was starting to recover successfully. It wasn't stuck in this unhealthy state. So again, pointing to our configuration set, our architecture, our system configuration as far as memory and and CPU and footprint are all, look to be sufficient for this particular run. So practical checklist, right? Of when you're running, to use WireMock Cloud as part of your load and performance testing. Some recommendations here, right? Make sure you use an isolated mock environment, meaning your mock API doesn't need every data source in the world, and it should kind of be operating on its own, footprint to avoid any of those noisy neighbors within inside of your own org. Always start with a clean baseline. I suggest starting with no delays, making sure the application is behaving, understanding we saw some spikes on the blue line during garbage collection in Node.js, understanding that's normal behavior, even when our upstream dependencies are fully healthy and performing at their best. We should expect to see garbage collection happening so that when we start to introduce some real world response times and some chaos into the equation, we're not mistakenly thinking, hey, this garbage collection is a result of those changes. No, they were there before we even introduced any of those issues. Then we look at adding the realism into the layers. This is where we added real world response times to our services. Making sure we model data variability. Again, we pointed this out with the use of dynamic response templating. Even though the mock API was rather simplistic, the responses coming back to our system under test, our consumer, were varied. So we were ensuring that we weren't doing any unnecessary caching and getting, false performance profile because of that, everything always being cached due to static responses. Setting those clear thresholds, right? This goes back to determining what does success look like, even at the microservice load performance reliability testing that we did. What are we comfortable? What error rate are we comfortable with saying is a pass, right? And understanding that, setting that up front so that we have clear boundaries, especially if we're going to take this last one, automate and compare, start to add this practice using WireMock Runner, a lot of the other pieces that we've introduced recently with integrating WireMock Cloud into your CI/CD process, maybe starting to include this practice into your CI/CD pipelines, where we're going to individually performance test and do reliability testing on our services as part of the deployment process. Right. So why WireMock Cloud for load testing virtualization there? We can control the realism. We have fine-grained control there. We can test using that scientific method, changing one variable at a time and watching what happens, seeing what we need to adjust, making sure that that testing is repeatable and it's being done in isolation, giving you that enterprise scale of achieving 5,000 to 20,000 transactions per second from your dedicated infrastructure of WireMock Cloud, and then reducing that operational overhead, not having to worry about building this out, maintaining the infrastructure, starting to add in all types of features that don't necessarily exist in open source tooling that's out there. So with that, that's what I wanted to share with you today. I have some questions for you all, kind of just to see this, and then I'll see if Ethan has collected any questions as well. I'd like to hear, where do your current load tests get stuck, right? Whether that is full end-to-end load performance testing or more on this microservice and individual service layer of performance testing. Are you even doing load performance reliability testing at that smaller, manageable service level rather than waiting all the way to the end of the SDLC to do it? What upstream dependencies cause you the most variability? And, do you test failure modes today under load, or are you just expecting everything's going to be roses and not injecting, those brownouts and those rate limiting, practicing bumping up against rate limiting, and replicating those random 5xx's and 4xx's we see in production logs, but can't necessarily replicate easily without something like WireMock Cloud. So, Ethan, do we have any questions that came in from the audience today?
Yeah, there are a couple. As a quick reminder, we will share the recording with everyone after. Please do circulate it internally, and we are happy to get on a call at any point. If you have any questions about any of this, if you want to just chat about your use case, anything like that, we are all ears. One question, Dan, that came up is how or does it impact it at all if I'm using the WireMock runner and the kind of new hybrid mode we've been talking about versus when I'm using a cloud host?
Sure. That's a good question, Ethan. So yeah, absolutely. So when when we shift to using the WireMock runner, right, we're getting a little bit closer to the WireMock open source style of challenges, where there is some tuning that you would need to be able to you would need to do to the WireMock runner container. After all, WireMock runner is deployed as a Docker container. With that comes a lot of dials and knobs to adjust container memory, container footprint. Where's that container running? And then even inside the container, the JVM, right, that WireMock runner is running on could still use some tuning in order to achieve your load level. So the recommendation, right, is if at all possible, just go against WireMock Cloud. Use the full-on cloud endpoints. That's the responsibility of Ethan, myself, the rest of the team here at WireMock Cloud to ensure that you're getting those 5,000 to 20,000 requests per second from your dedicated infrastructure. And we take that burden on, right? We scale when we need to scale for you, noticing that maybe your dedicated infrastructure needs a little bit more horsepower to achieve the limits you want. We'd rather do that for you and take that burden off your shoulders than you having to do it with WireMock Runner and, of course, with WireMock Standalone.
You kind of just touched on actually the next question. But maybe just to push into that a little deeper, we got a question on, do I have any concerns about scalability at different sizes of load when using WireMock Cloud? Or how does WireMock, rephrasing the question for them, I guess, how does WireMock Cloud handle the scalability? Do they need to be in touch with us? Is there extra cost for scalability? What can we say about
Sure.
things like that?
Yeah, great question. So first and foremost, there's no extra cost for increasing the dedicated infrastructure. That is all part of your subscription with WireMock Cloud. Um, Today WireMock Cloud is scaled vertically for the dedicated infrastructure. This is something that we will be working on in the very short term. Ethan might be able to talk a little bit more about that if we're ready to talk about that. But approaching a horizontal auto scaling capability is something that is very interesting to us. But today we're scaled vertically. We have monitors and alarms monitoring everybody's piece of dedicated infrastructure. We can see when resources are being constrained, and typically when that happens, if that happens, which it rarely does, a quick reach out from us to our customers and saying, "Hey, we see that you're running some really high levels of load, and we'd like to increase your footprint. Is that okay with you?" Again, completely at WireMock Cloud's cost, not yours as a customer. That's typically how we handle it today. But we see that being vastly improved in the near future as we embark upon horizontal autoscaling.
Yep, I think that pretty much covers it. And I will say, just to add on to what Dan said, given that most of our customers do load testing over the course of their usage of WireMock Cloud, it is an exception when we have to get involved at all. For the vast majority of customers, it works completely out of the box. Once in a while, at particular scales, we will, like Dan said, get involved to reallocate the resources just a little bit to help out at no added cost. As far as question goes, it looks like that is it, unless anyone wants to sneak one in here last minute. So we'll send this recording out to you. We will post soon what the WireMock Live will be about a month from now when we do the next one. And for those of y'all who are still here, we will reach out by email if you are the winner of the Sony noise canceling headphones giveaway. Thank you again for taking the time to join us today. We do appreciate it. If you have any topics you'd like to see, anything about WireMod Cloud, anything along these lines that you feel you'd like to understand better, we are very receptive to topics for future sessions, so feel free to reach out on that as well. And with that, have a great day, everyone.
Thank you all.